So hi everyone, I'm Nicolas.
And I'm John Hoford.
And today we're going to talk about what's up with ConstraintLayout, what we have today, and what are some of the plans for the coming months. First of all, thanks to everyone. Thanks to the organizer for this conference. It's definitely a little unusual to give a conference like that. So hopefully, it will be a good experience for you too. There's a chat. We'll try to answer some of the questions, but let's go with the talk for now. What is this thing? Hopefully a lot of you know what ConstraintLayout is, but just a quick recap. ConstraintLayout 1.0 was focusing on being a very flexible layout manager. The gist of the idea was you want a layout manager that lets you position widgets relative to one another in a very easy way. And it can do a lot more than that, but that was kind of like the gist of the idea there. Another important stuff that we carried on ConstraintLayout 2 was the concept of having helper objects that they are present, but they are not automatically visible on your screen, and their role is to help you create your layout in a much simpler way. And finally, the critical things that we saw in 2.2 as well is the idea of being able to encapsulate all the rules for a layout into one object, constraint set. And that allowed us to quickly swap in and out those layout rules. And another important part of ConstraintLayout 1 was, of course, the support on the Android Studio layout editor. So that's where we were with ConstraintLayout 1. And example of the design tools, you can see you can build UI very easily and pretty fast. So ConstraintLayout 2, what's the difference between with that and ConstraintLayout 1? One big thing was virtual layouts. The idea was to keep things even more flexible by having those helpers objects that help you position this element, but in a much more powerful way. So we'll cover that a little more. We also added new functionalities with helpers and decorators to make more shiny stuff on your screen. We beefed up the programming APIs, and more importantly, or more obviously, we introduced MotionLayout. It's a new layout that really helps to create animated screens, essentially. And in the same vein as the layout editor, we worked on a motion editor in Android Studio in the upcoming Android Studio 4.0. So just to recap a few things, because I've seen several times people get a little confused with ConstraintLayout and the different layouts that you have available on Android. So typically, I believe that those are the layouts that you need. No more, no less. You can always get layouts that are more specific, more tailored to your specific needs, but the bulk of your layout needs will be completely addressed by those three layouts. Frame layout is just something where if you have one element that you want to display it, there is no need to bring all the heavy machinery of ConstraintLayout. So do use frame layouts. Same thing for linear layout. If all you have is a row of buttons and that's all you want in your screen, then linear layout is completely fine. For anything else, ConstraintLayout is there. And one thing I would mention as well is that it is okay to use a linear layout inside a constraint layout if that makes your organization better when you create your screen. So those things can be mix and match as well. That said, constraint layout can do a lot of the things that linear layout does as well, right? I mentioned that linear layout can be very convenient when you organize your screen. And that's why in 2.0 we introduced a virtual layout called Flow. So the thing is, often when you create your screen, some of the elements you want to position them relative to one another, but there is another category of positioning that's about taking a set of widgets and positioning them as a group. And in ConstraintLayout we introduce the concept of chains, which is a very powerful concept that allows you to position those elements as a group, so taking all those elements together and doing it on one single axis of either horizontal or vertical. The problem with chains is that it gets it gets a little tricky when you edit your XML to set up all those constraints. It's not as clear-cut. It's not as straightforward as if you add everything into a single group, right? And that's why some people prefer to use a linear layout in that situation. And the problem, though, is that if you want to take advantage of some of the advantage of constraint layout in terms of keeping things with a flat hierarchy, which has a lot of bonus when you try to work with animation, then encapsulating things into a linear layout is less convenient. So in 2.0, we have Flow, which essentially is kind of like linear layout, but does it essentially within constraint layout. When I say it's like linear layout, it actually does a lot more as well, and we'll cover that quickly. So how does it look like? You typically have your element, and you simply reference objects. Here in that example, A, B, and C, but otherwise, that flow element is a widget itself, so you can position it exactly like you would expect. So in practice, you can manipulate it like if it was another view group, but internally, it doesn't add any additional layers. And more importantly, you can still swap on the fly those rules. So Flow supports multiple modes for positioning those elements. The base things is we can essentially replicate what chain does, but within that framework with Flow. But we do more, and as I mentioned, yes, you can do chain, but you can also apply it to do things that are a little more like flexbox layout, where elements would automatically wrap depending on the available space. Quickly cover on chain. So what does that mean? It means that if I have those three elements, I can apply the same chain styles that you may be familiar with constraint layout. So the spread chain, or a spread inside chain, or a packed chain, all of that is available in Flow. It just essentially, you can think about it as a nicer way to work with chains. We also support wrap chains, which is a little more like this flexbox behavior, where essentially when you don't have enough space, to put all your widgets, we would automatically go to the next line. We would wrap that chain, and it works horizontally or vertically. And in fact, you can even specify the type of chain that you have for the first chain or the last chain and stuff like that. So it is very flexible. So here in that example, I have the first line as a spread chain, the last line as a packed chain. You can also specify the number of maximum elements before you wrap. Now, if you look at that, it looks awfully close to what a table would be. And the problem is, it's not, because, well, the elements are not going to be aligned. And which is exactly why we added a wrap align mode that essentially make it a table. So that's an easy way of simply referencing a bunch of elements and applying them, layout rules like that. Now, for motion layout, John is going to talk about that.
Yeah. So, what is motion layout? It's not. Motion layout is, next slide. Okay. Motion layout is a tool for building layouts that are animated or interact with touch or button clicks. So basically, how does that work? You start off with a view group, and then you add constraint layout on top of it, and motion layout is a subclass. So because it's a subclass, you get all of this stuff that you normally see in constraint layout, but now you can add motion to that. So what does it do? you can position your views just like any layout can. You can control a series of states so that in MotionLayout, you have a concept of constraint sets, which is from the original, but we sort of think of them as states of your layout. And you can switch back and forth between different states. And in switching between those states, you achieve animation. And on top of that animation, you can actually drive the animation with touch handling. So let's see how we put that stuff together. First, we want to transition between states. So we have a start state and we have an end state, and we have a transition between them. And because we have this concept of keyframes, you can actually modify how you get from the start state to the end state. The default would be simple sort of linear interpolations between the two states, but you can actually modify them within the transition. And in fact, you can have many states. You can have as many states as your application needs for that particular layout. So what we have is a separate file for storing all this information. So it's not actually stored within your layout. It's stored within in the XML directory in something we call a motion scene. And so a motion scene consists of multiple states followed by two constraint, a transition between those multiple states. In this case, we have two constraint sets and one transition. Okay. But it's also to remember that you can think of the base state as the actual layout file, so that in fact your constraint sets are actually sort of derived from that base layout, and you can have it as a simple modifier. What's inside of a constraint set? A constraint set will have actually the constraints very much like the constraints you would see inside of a layout file. It'll have like the layout width, layout height, a constraint, a layout constraint at top of top or whatever. You know, the typical kinds of stuff you see in a constraint in layouts, in constraint layout. Transitions, on the other hand, have three things. You can have an on-click, which is when you click on a button and how it should transition. On swipe, if you want to have swiping control between things. And you can have keyframes, which are the modifiers that allow you to change the path of things. When you talk about a keyframe, you have 5 different types. And they all kind of do different things. The only one that actually modifies your view bounds is the key position. And that has to behave a little bit special because it has to deal with the fact that the views are occurring on different screens. I mean, part of the point of constraint sets is that views get laid out according to a complex series of rules that interact with your screen size and that sort of stuff. To help you with that, we've put in 3 different coordinate systems within a key position. The first one is parent relative. That's sort of the simplest. Essentially, you think of it as absolute positioning within the parent. So if you say 0, 0, it will be all the way to the top left. The drawing on the right is flipped. The next one is delta relative. This is, we know that the view is going to move from one point to another point. We want to make the motion relative to that motion. So the one 1 would be where it's going to end. 0 is where it's going to start. And the x coordinate is in the x-axis and the y coordinate is in the y-axis. Parent relative rotates that so that the x-axis is in fact along the path and the y-axis is perpendicular. And there's several different reasons why you would choose one or the other. Generally speaking, I recommend using delta relative until you're not getting what you want out of the behavior, and then consider the other two. Just to touch on a couple of different a couple of different other tags. One of them is key cycles. Key cycles allow you to build any kind of oscillatory behaviors because it would be way too difficult to code complex paths like this if you were to use a bunch of different key positions to get it. These will affect view bounds. These won't affect view bounds. These will affect the affine transform that is a post-layout transform that all Android views support. The other one that is key time cycle, which is a little different in the sense that the oscillations in the previous one, key cycle, oscillate with respect to the animation path. These oscillate with respect to time. So if you're stopped halfway through, let's say in the middle of a swipe, it will continue to oscillate. And we'll see some more examples of that.
Okay, so yeah.
Now Nicolas will compose.
Yes. Bear with us. We are still practicing this whole remote talk. It's not that simple. All right, so let me talk a little bit about what are our plans for Compose and Constraint Layout. We heard loud and clear a lot of people want to use Constraint Layout in Compose. So Compose brings a series of layout manager that essentially you can think about it as the equivalent of a linear layout mated with a flexbox layout, right? You can have rows and column and stack, but in the same way that on Android we originally had relative layout and now we have constraint layout, the ability of positioning your elements, like your widgets, relative to one another can be super convenient when you build your screen, and particularly for people that are used to the vocabulary of constraint layout on how you can build up a screen with constraint layout. It's kind of nice to be able to access constraint layout there. So the good news is it's actually it's actually in Compose right now. You can try it. I think I don't remember exactly which dev release we did it, but it's definitely there now on Dev 9. I think it was Dev 7 or Dev 8 maybe. But basically, the gist of it is that we are sharing code with the existing constraint layout library, and we focus on building a DSL so that you can express your constraints. So you got the typical advantages of having a DSL. You can refactor code and et cetera, and you have a good behavior in the editor, and you got your constraints at the same place as your code in that case. It's also a work in progress. So specifically for the DSL, we're still iterating on it. So now is the right time to give it a try. And if you have comments, to tell us, because we want comments. So here's how it looks. So you have your composable. And essentially here, I just took the basic greeting example that you have on the tutorial that receives those strings, and you want to display a text with that. So here I've got two composable, a text with hello and whatever name that you passed as a parameter, and I added a with constraint layout. The main difference is that we add a modifier tag that will identify those two elements. And then we pass or we create inline or as an external variable, a constraint set that will be this famous constraint set I talked about before that describe your entire system of constraints. And as I said, again, because it's in code, it doesn't matter for us if you create that somewhere else and you reuse it, or if you create it inline. A basic example would be something like that, where you create a text1 tag and apply here a center. And center is just a shorthand to just use center in parents horizontally and vertically. So the element text1 will be displayed in the middle, and text2 will be displayed relative to the parent and on the bottom right of the screen. And this is kind of what you end up with. So again, it's still relatively early, specifically in terms of the tooling that we have in mind in Android Studio to support that in a nicer way. So we will do more than what we have today, but it's already usable. And again, please give us comments, and if you have ideas or specific feedbacks on the DSL specifically, right? Okay. I think at that point, we went through it a little quickly, but you should have a good idea on what is constraint layout, what is motion layout, and where do we stand relative to Compose. If possible, right now, I'd like us to switch to the polls. Can we do that? So there's a couple of surveys, yeah. So specifically about, have you used constraint layout? Have you used motion layout? And okay, it seems like a lot of you are using constraint layout. And it's going to switch back on the motion layout one, just to an idea. And most of you have not used motion layout, which is a shame, really, because it's really cool. And we'll cover some examples to give you a better idea of the capabilities of motion layout and what you can do with it. Let's start first with constraint layout, actually. Just a basic example on inflow, just to give you a better sense of it. So imagine you have this kind of screen with, you have this typical grid-like structure that you want to do in your layout. You can actually do it in constraint layout with chains. It will be a lot of constraints and a lot of stuff to build manually. Bear in mind, by the way, that we do have a lot of tools in the Studio Designer to help you build that. So in fact, it may not be even too hard to build up that using the layout editor. Where it's going to be annoying is maintaining that going forward, because you're going to have constraints all over the place. And really, this is a great structure. We should be able to represent it in a nicer way. So we'll do that with a flow. And the nice thing with that is you don't have to create a specific background view that you somehow hang over the different elements you want to construct. No, here you just say you have that flow. Here, that's the yellow part. And it references all those different buttons, and that's all. We can set up on the flow itself, because it's a normal view, we can set up a background. Here, of course, a very tasteful canary yellow. Now, how does it work in XML? Again, it's a normal view. So you have your typical layout width, layout height. Here I set a background. You can set up a padding. It's a normal view. It has an ID. It's as usual in constraint layouts. And in fact, you can constrain it as well. So here I'm just centering it in the parent. The only thing different is those lines. And you got the reference IDs line that essentially will list all the elements you want in that flow. And then you have a bunch of attributes that you can set to decide how you want that to behave. And here, for example, I'm wrapping after 3 elements, I have some gaps, etc. So this is what you end up with. And it should be, one, a lot easier to build, but also, and that's what I'm more interested in, it should be a lot easier to maintain going forward. Now, what is nice is, because it's still in constraint layout, it's not an added level of hierarchy, you can still position other widgets directly relative to those elements that Flow have laid out. So here, if I want a header for my little calculator, I can literally just constrain it to the flow itself, because the flow is a widget. But reversely, or additionally, I can create another button that will directly point to those elements laid out by Flow, right? So you still keep this flatness that can be very convenient for this type of things, right? Essentially, you could imagine that if it was a nested hierarchy layout, you'd be able to do cross hierarchies. It's a little bit like that. The other advantage is that because it's understood by constraint layout, it's understood by motion layout. And so you can do things like that in motion layout, where you see that first element, the pink one, gets in the second state of motion layout, gets moved out of the flow, and its constraints are defined somewhere else. So here we just make it like, on the left side of the screen. And I am also changing on that second state, I'm also changing the orientation of the flow. So yeah, so essentially that's what flow buys you. It should be easier to build up your screens, and it's understood by motion layout, so you can do really interesting animation like that. And now to talk about specific motion layout example, John.
So because a lot of you have never used motion layout, at first I really wanted to talk about things you would actually want to use it for. Like, why would you want to use motion layout? And the very first thing you want to think about, the sort of almost the simplest use case, is if you just want to have an attention-grabbing screen, whether it's for an upsell purpose or a purpose of trying to get to introduce your new feature, your new component, a fly-in animation is another example. So here I've just done a typical example. It's kind of crazy. It will provide you with a lot of visual excitement. One of the big wins of doing this within motion layout and not doing this within, let's say, Lottie or some sort of pure graphic, these are actual live widgets being rendered here. So if as part of that screen you have an upsell or you have a login here now or whatever, it's sort of integrated tightly within your application. It's not, oh, I have graphics here and then I switch you back to your work. You can actually have it part of your login screen, etc. The next use case, traditionally animation would quickly break as your application evolved, and then you end up abandoning it. Okay, so we're back. All right, so we'll kind of go through these a little quickly. So one of the things that you can do is you can build something based on coordinator layout. So if you have a coordinator layout application and you just want a slightly fancier top bar or bottom bar, it's very simple. You just subclass motion layout and you add this code to it. You basically override the on-offset change listener. Next.
All right. So same thing for
the same thing applies for view page. You basically are doing your subclassing. Same thing would apply for draw layout. So it's very simple to do all of those. Now, one of the things that you could start to do is do your own types of fly-ins, which is basically where you're doing a custom complex fly-in. And the way you do that is you build your constraint sets, your constraint layout. You just do everything in constraint layout the way you normally do it. You sort of lay out the piece that's flying in that needs the pull right menu, and you will then push it off screen, and then you will convert the top level to motion layout, and then you change the constraint sets. In this particular case, you'll see the last two I change the constraint set from start, which is just attached to the left, and the starting state is to end of start, which is attached on the outside of the screen. And then the other thing I do is I added a rotation in the y-axis. So the overall effect you get when you make those two simple changes is you get a pull right menu that with a completely weird twist to it. And notice that none of the code is really complex. In fact, it's simpler than implementing a typical menu like this. Now, you can do a similar thing where you take over and implement your entire coordinator layout yourself. And in this case, I just built it. And we have a lot of these examples and a lot of examples like this on our websites. So another use case is where you do custom widgets. So you needed to implement a dial or any kind of meters. You can imagine you can build one and they will animate and they will operate just fine. These were custom, and we'll share some of the code. Another example here is a bunch of different kinds of animations that you can achieve. All of these kinds of things are relatively simple, and now you have a custom widget that can build you something that can be used within your application, but it's also very simply assembled in XML. And so someone needs to go in and change it. It's not a complex thing. It's very manageable work.
So I think this is kind of like the big stuff with MotionLayout is that you can use it to control your entire screen, like coordinator layout, but in a more straightforward way, or it can go down to animating or doing the animation for a single widget. But another part is actually being able to do that programmatically, and that opens up a lot of doors. I'm going to go through that very quickly because we won't have time to cover all of this. But just briefly, if you have a recycler view, you could do a bunch of stuff to essentially use a motion layout to express the motion. The gist of it is that you create your animation in motion layout, and at runtime, you change the position of what that animation was, for the stuff you're animating, to correspond to the actual position of the recycler view. And it's a bit of work, but then you can express an animation and apply it to that recycler view. And you could think about, why do we do all of this work? Well, now that it's actually expressed in motion layout, it becomes trivial to tweak it. So here I'm adding a key position, and now you got this slightly different effect for the animation, or applying a rotation, and again you can have something different. So that's kind of like the advantage of switching your animation in motion layout like that, is that it then becomes a lot easier to tweak. We have an example, you can find it online, about how to build a complete scene in motion layout completely programmatically, which is not automatically what you need all the time, but it can come in handy. And this was more like as a proof of concept of, you don't have to use any XML if you really don't want to use XML. A quick example, and if you have a carousel pattern like that, essentially if you know about recycler view, this is kind of what recycler view does, how to do it in motion layout. Same thing, once you express the problem in motion layout, you have a lot of additional power to it, right? So you can create your different states. The gist of it is really those two lines where I reset the progress of the animation and essentially I fake a recycler view and then update the image. And what's nice is that then you can basically, you are in complete control of your scene and you can do really interesting effects. Okay, just to recap. So for constraint layout, the thing that I'd like you to get out of this talk is that it starts with a simple model or just relative positioning, but it can evolve to really powerful behavior. And don't look at it as this overwhelming set of features. Understand the very basic one about I'm positioning something relative to another, and you can build up your knowledge from that. But the goal is that you won't have to switch to code. In 99% of the situations will be handled by constraint layout. We also, spend a lot of time, working on the design tools integration, and it's there. Use it. It's also okay to use linear layout if that makes more sense for your situation. And finally, if it's not, and you want good behavior rather than chain, I would really advise using flow in constraint layout too. And in motion layout, John?
Yes, in motion layout, the main point here is that it's easy for creating animations. You won't have you'll have a lot of tooling right now, it's a relatively straightforward model where it's start and end, so it's very easy to. It's also very easy at modifying because you can actually graphically modify, and tomorrow you'll see some of those tools if you come to our talk. And so you can graphically make changes and tweak the animations on or live on your screen. And because of those two, it's actually a very sustainable model. It separates your logic from your code, from your UI, and makes it easy to you to say, oh, the next version we need to add a new widget. It's very simple to add it. It's not going to be too complicated. Unlike where it's a very complex piece of code. And that separation of logic is critical.
Okay, so very quickly, we are out of time, but where are we standing with ConstraintLayout 2? Well, we are going to release beta 5 this week, I promise. I was actually hoping to do it this morning, but we ran out of time, but I think by Wednesday will be good. Beta 6 is going to come in, within the month. Probably, we hope it's going to be the release candidate and be promoted to the stable release. So far, it's looking good. And the goal really is to ship ConstraintLayout 2 final as the same time roughly, or even before we ship 4.2 final on Android Studio. We would also like to move to GitHub, and we think that might make things a little nicer, both for us and for you if you want to look into the implementation or contribute. Just in parallel, we are doing a lot of work in the design tool, so keep that in mind. In Android Studio 4.0, there is the motion editor for motion layout, but we also have other design tools like Layout Inspector, layout validation, and all the other ones like Navigation Editor and all Layout Editor we released. Tomorrow we have a talk about the design tools more specifically, so I encourage you to go and check that out. In 4.1, we're going to focus mostly on essentially refinement, some things that we pushed out of the 4.0. And going forward, we are going to focus a lot on design tools specifically for Compose. So post 2.0, and we hope to get that very quickly after 2.0, we are going to release a 2.1 release of ConstraintLayout. Essentially, it's a lot of the stuff that we decided, we should not do that in 2.0. So that goes from relatively minor things like adding margins on baseline constraints to very cool helpers ideas we have for motion layout and things like that. And what we would really like to get to as well is much higher velocity so that you don't wait a year for the 2.1 stable. And we'll try our best. For ConstraintLayout Compose, we actually released last week or 2 weeks ago maybe a separate library called ConstraintLayout Core. And the idea is that going forward, ConstraintLayout Android and ConstraintLayout Compose will share the same library. Right now, it's kind of there, but going forward, we'll make it like that. Beyond 2.1, we might actually start introducing some compatibilities, some breaking compatibilities features, just to take the advantage of getting something a little cleaner. But we'll see. And that's all. We are a little late, but some documentation is available both on MotionLayout and ConstraintLayout. We have a GitHub with a bunch of examples that we showed today that's available. We'll actually update that very soon with some of the new one we didn't add yet, but we'll do that this week. And that's it. Remember, there is a bug tracker, and so if you are using the library and you have issues, please file the bugs. We do go through them. Thanks, everyone. Sorry for the technical glitches, and thanks to the organizer.
Yes, thank you. Bye-bye.